So in 6.7, we're more than likely going to break this lesson into 2 parts, which means we're going to check this homework on Thursday, but by the time we get to the end of this part of the lesson, you should be able to do most of the homework still tonight. It's just we're not going to check it till Thursday. All right, so probability and odds is what we're learning today. So what is probability? You need to write this down. Probability is the likelihood that an event will occur, good or bad. Okay? Good or bad. So maybe we want it to happen, maybe we don't want it to happen, but probability is the likelihood that it will happen. Okay? So we use probability to calculate risk and make decisions. We talked about insurance policies. We talked about, that one thing that we think would be really, really cool to do, bungee jumping or scuba diving with sharks or, skydiving. But calculating the risk involved in that once-in-a-lifetime experience and whether or not we should actually take the risk. And then we also use probability to make predictions. Okay? You may or may not have heard the saying, but there is a lot of truth to this saying, that the best predictor of future behavior, good and bad, doesn't necessarily have to be bad, but the best predictor of future behavior is past behavior. Okay? And that's why when you're applying for a job, they ask for references. Why do they ask for references? Well, because they want to know what other people think of you. And if other people who know you or have known you for a long time think that you're a really hard worker and they have specific examples, that gives the future employer more of a guarantee that you will be a good employee for them. Does that make sense? Okay, so their risk in hiring you gets much lower when you have strong references. So yeah, don't ask that teacher that you always give them a hard time, not necessarily me. Okay, maybe don't ask them for a reference. All right, if you need one, okay, ask that teacher where you were like an angel for them. You were so good, right? Okay, so anyway, the best predictor sometimes, unless other changes occur, and listen, if you have a reputation of, not good behavior, it doesn't mean that you have to be bad forever. You can make changes. All right, obviously, God can help us make those changes in our life to be better people, okay? But we definitely can use probability to also make predictions. We're going to do that in example 3 today. All right, look at my nice little chart down there, my elephant ballerina, okay, all the way to the sun coming up in the morning. All right, and this gives me a scale, on a scale of 0 to 1, of the likelihood of something happening. In the bottom part of the scale, if the likelihood of something bad to happen is out there, and that's what I'm assessing, I want it to be in the bottom part of the scale. For example, the likelihood that I'm going to get some type of terminal illness, like cancer or something, I want that likelihood to be as low as possible, right? Like 0. All right, we don't want something bad to happen. But can you think of something that you would want a really high probability of it happening or occurring? TJ? Winning the lottery. That is the number 1 answer. Okay, so I've heard that all day today. Yes, winning the lottery. Absolutely. If we knew we could win the lottery, I think we'd all go buy a lottery ticket, right? Okay, because that's something really, really good. Sadly, it's just the opposite, right? The chances that we win the lottery are so minuscule that it's, it really is kind of just, yeah, exactly. It's not even worth wasting our money on. All right, so probability, definition, when do we use probability? We actually use it a lot more than we realize. All right, and other people assess probability and risk assessments on us all the time, whether we realize it or not too. All right, so there's 2 types of probability that we're going to learn today. The first type is experimental probability. The second type is theoretical probability. There's one main difference between the 2. With experimental probability, you're actually taking action on whatever you're assessing, okay? So you're actually doing the experiment, action. With theoretical probability, it tells me what's supposed to happen based on the statistics, but it's not an actual test or an actual experiment of whatever I'm measuring, okay? And you'll see a better example of that in just a second. All right, you also need to make sure that you write down both formulas. The good news is that both formulas are essentially the same thing. They both assess favorable outcomes, and that's success, right? Would you agree that favorable is the same thing as successful? Yeah, success, okay? Favorable over possible. And this really is the cornerstone, guys, to probability. You're going to learn probability all the way up through Algebra 2 and higher. Probability, if there's any concept that I can guarantee is going to be on your college entrance testing, SAT, ACT, dual enrollment, it is probability. When I took my state test to become certified to teach math, probability was a big piece of that. Okay? It's one of those concepts that it's not going to go away. And this is the cornerstone right here. To assess probability, it's what am I measuring? Okay, what event am I measuring that's maybe going to happen, okay, out of how many possible chances are there of that event happening? All right, you got it? No. Okay, all right, favorable over possible. All right, I'll give you another minute. All right, so we're going to look at the difference between the two of these with the flip of a coin. Okay, so theoretical probability, all right, so we've got a coin here. Theoretical probability says the probability, and I'm just going to pick heads for no reason, okay, just had to pick either heads or tails. Probability of heads is how many possible outcomes are there? 2 possible outcomes, heads or tails. How many outcomes of those are heads? 1. So the probability, theoretically, that I flip a heads is 1 out of 2. Okay. However, what if I actually put this probability to the test? What if I actually experiment and flip this coin 10 times? So now the probability that I get heads. All right, and I'm going to pause the recording while we do this experiment because it's going to take a few minutes. But let's go ahead and flip the coin 10 times and see how many times it lands on heads. Okay, so she flipped the coin 10 times, and out of those 10 times, 7 of them were heads. So the experimental probability, what we can see here is that experimental and theoretical probability for the same experiment are different. And what the conclusion we can draw is that sometimes, even though on paper it said, well, I got a 50-50 chance, I have 2 sides, 50-50 chance of flipping a heads, the actual likelihood that I flip a coin 10 times and I land on heads 5 times is actually pretty slim. So theoretical and experimental probability of the same experiment usually are not the same. Okay? Now, and I think it was my first class, it actually was the same, but that rarely happens. Okay? Yeah, I got 5 heads. Okay? So 2 types of probability. Let's look at another scenario, a number cube. Y'all know the number cubes that you play board games with? How many sides are there on a number cube? How many numbers? 6. 6 sides, 6 numbers on a number cube. Okay? So there's 6 sides to a number cube, and so that's my total possible outcomes is 6. All right, so now let's see what we're being asked to measure. What is the probability that you roll an even number? This part is important when you're setting it up, and I will take off if you do not have this on your homework. Probability, what are you measuring? What outcome are you measuring? Here in the first one. Roll a even number. So you write that. Roll an even number. You write that in parentheses. That's what you're measuring. That's your favorable outcome. So how many even numbers are on the number cube? 3 out of 6 reduces to 1/2. So theoretically, your probability is 1/2. Now, if you actually did that, the experimental probability, it might not be 1/2, but in theory, that's what it should be. 1/2, 50%.
Are we going to roll
All right, so now what I want you to do is read the next question and fill in parentheses what it is we're measuring. What is the favorable outcome or the targeted outcome for this question, and then try to set up your ratio. All right, so what am I measuring? Probability. Roll a number, you can abbreviate, less than 5. All right, and what you write in parentheses, it might be a little different from person to person. That's okay. That's no big deal as long as it's in the ballpark. All right, so how many numbers are less than 5 on a number cube?
4.
4 out of how many? 6 reduces to 2/3. 2/3. All right, now probability, what am I measuring on the third one? Roll a 4. All right, well, how many 4s are on a number cube? 1 over 6. That's my probability that I would roll a 4. It's just favorable over possible. That's it. Okay, that's what it comes down to. Any questions on finding probability? All right, so now let's talk experimental probability. Here's the main difference. What we are measuring is actually being executed. There is action here in this example. A miniature golf course offers a free game to golfers who make a hole-in-one on the last hole. It's not just an idea. They're actually, putting the last hole. And last week, 44 out of 256 golfers made a hole-in-one. Find the experimental probability that a golfer makes a hole-in-one on the last hole. So I want you to tell me what it is we're measuring. What's my targeted outcome? What's my successes over my trials? Okay, and then reduce it.
People who make a
Yeah, we're measuring hole-in-one. Okay, how many hole-in-ones were there? How many successes?
44.
How many attempts? 256. What does that reduce to?
11 over 64.
Okay, 11 over 64. Now with experimental probability, I also need a decimal value. So what is 11 over 64 as a decimal?
0.75. So 0. What are we rounding?
Just round to the nearest hundredth. It should be 0.17, shouldn't it? Yeah, so about 0.17. We're rounding to the nearest hundredth. Okay, so 0.17, that would be fine. Now, the decimal value, I'm going to tell you this, is only important if I have to make a prediction. So in this scenario, if it said predict, based on the experimental probability, predict how many people will make a hole-in-one next week, then if 300 golfers, come through, then I would use that decimal. All right, and we'll talk more about that in example 3. But the decimal is only needed if I need to make a prediction about what's going to happen. This is just telling me what already did happen with the golfers who came through last week. Does that make sense? So let me ask you this. Is there a high probability that you're going to get a hole-in-one? No, that's based on the numbers. Not a whole lot of people get a hole-in-one. So the golf course really isn't giving away a ton of free games, are they? Only 17%. Okay, 0.17. That's not a whole lot. All right, so we can make conclusions too based on probability. Again, based on that scale of 0 to 1. All right, so here's another scenario. You interviewed 45 randomly chosen students for the newspaper. Of the students you interviewed, 15 play sports. Find the experimental probability that the next randomly chosen student will play sports. All right, so go ahead and set it up and solve. Again, experimental probability, you will want that decimal value also. Okay, so what are we measuring? What are we measuring? Probability of what? Yeah, probability that a student plays sports. Okay, so probability that they play sports, so that's what I wrote in parentheses, all right, is 15 out of 45, which is about 1/3 or 0.3. Okay, and again, we don't need the decimal because we don't have to predict something to happen in the future, but you can write either one and that would be fine. One more example. Okay, in the last example, we're going to use probability, experimental probability to be specific, to make a prediction. Okay, so it's a basketball example. It says today you attempted 50 free throws and made 32 of them. Use experimental probability to predict, based on your success today or failure, depending how you look at it, to predict how many free throws you will make tomorrow. All right, so again, we're setting up successes over attempts, find our decimal, and then we use that to make our prediction. All right, so probability of what? A missed free throw? No, made free throw. How many did I make today?
32.
How many did I shoot?
75.
50. So reduce it. About 64.64, 64%. So now I use the decimal value to multiply by how many I'm trying, to predict I'm going to make tomorrow. 0.64 times 75 equals, if I go on the same ratio as I did today, I'm going to make about 48 free throws. Okay? So experimental probability, find your decimal value, use your decimal value to multiply by the total for the future, and that helps you predict how many you're going to make. Again, the best predictor of future behavior is past behavior, right? Does that guarantee that I'm going to make 48 tomorrow? Does it guarantee it? No, because maybe I wake up with a stomach bug and it messes me up, or maybe, there's a lot of things. Maybe my wrist is hurting tomorrow, so that throws off my shot. There could just be a lot of things. So it's not a guarantee, but I'm trying to predict for the future based on the past. Does that make sense? Okay? And really that's all we can do. There's no guarantees. One more. Okay, so this is a different scenario. Trees. You plant 30 red cedar tree seeds and 6 of them sprout. Use experimental probability to predict how many seeds will sprout total, insert total, if you plant 25 more seeds. So use experimental probability on the first scenario, figure out your decimal value of the success, and then use it to predict how many would sprout out of 25 more seeds. Okay, so successes over trials on the first plant was 60 over 30. Did y'all get that? 1/5 or 0.2. And then what do I do to predict how many would come out of the second planting? Multiply 0.2 by 25, and 5 more seeds will turn into sprouts. So now, how many does that make total? 11. 5 plus 6 is 11 seeds total that will sprout into trees. Okay, guys, hold on. Let me finish up here. Hold on. Hey, listen to what I'm saying here. Are you listening? Okay, so I can use this type of data to determine whether or not I do want to plant a second time. Let's say I planted 30 seeds and 1 of them sprouted into a tree. Am I going to spend more money on seed? No. But if I plant 30 of them and 20 sprout into trees, then I know that that was actually worth the time and effort and money I put into planting them. So, guys, you can use experimental probability to help you make decisions on what you're going to do in the future. All right, and that applies to a whole lot of things. All right, so hopefully you learned something today. Part 1 is done. The only thing we're going to do tomorrow is odds in favor and odds against. Everything else you should be able to complete on your homework assignment tonight. Okay, do not wait until tomorrow to get it done. All right, and that's it for part 1 of section 6.7.